Hi guys, in this series of videos we'll start by looking at gravitation with spherical masses, then we'll look at field strength, gravitational potential, potential gradients, then we'll finish with an exam style question.
So let's start off by thinking about gravitation with spherical masses. So far we've only worked with point masses. Everything we've done has been centered around having a particle at a point, and we've come up with Newton's law of gravitation, etc., with that in mind. Or the distance we've been working at are basically so large that any object we've encountered can be approximated as a point particle. For instance, if this is, say, the Earth here or something, if we think about distances that aren't so close to the Earth's radius, rather than think about distances out to here or out to here, where you think about it, the Earth's radius is, well, this distance, and this distance, you know, the radial distance from its centre out to here or out to here are very close to it, so we can't ignore that the Earth is a sphere at that point. But instead we look at, you know, the distance between the Earth and the Sun. We're talking about distances like this. That's so big that the Earth might as well just be a point particle there. And so those are the other approximations we made, where basically and this has been based around the questions we've done as well, where the distances are so great that the particles we're talking about, even though they may well be spheres rather than point particles, they might as well be point particles for all of the purposes and that we're interested in. So, but it actually turns out that was an unnecessary step to take. We didn't need to do that, because there's really no need to, because it turns out that everything we've done so far works exactly the same for spherical masses. So we never needed to we never needed to approximate the Earth as a point particle in this setup when we think about the Earth moving around the Sun or the Earth or the Moon rotating around the Earth or anything like that, because all we needed to do was simply treat all of their mass as if it was concentrated in the centre of the object. In other words, we can treat the Earth exactly as if it's got basically a point particle in the centre of it, where all the mass is concentrated. So this was us thinking about a point particle here, and the gravitational field around it. But it turns out that that's exactly the same field as a spherical object has. It's as if we've basically just got a point particle in the centre here that has exactly the same properties as this point particle here. So if this is a mass of m, then this particle, this point particle, and this sphere has a mass of m, then it's like it's got all of its mass m just put at the centre of it, and it has exactly the same field. So it works exactly the same as we did before. So all the forces work exactly the same, as if we can use exactly the same force law, exactly the same stuff with potential. It's just as if the mass is at the centre, concentrated at the centre of this object. It's centre of mass. And otherwise, we can basically forget that we've got a sphere, and we can just pretend that we've got a point particle. So we don't need to worry about that. Up to a point, because actually it turns out we do. So it is just like we've got a point particle.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.